Good morning, student. I welcome you for in our today's lecture. And in our today's lecture, we will study the concept of modularity. And this concept is related to your software design. Okay. And after that, in your modularity, there are two approaches, that is cohesion and coupling. Okay. What is cohesion? What is coupling? We will study that. Okay. First of all, we will go for a modularity. Modularity means you are dividing your project into different modules. Okay, or you can say that you are decomposing your program, a complete program, that is your project or your software is. That software program or a source code is decomposed into different modules. Okay, that is the simple definition of your modularity is. First is software modularity is the decomposition of program into smaller programs with a standardized interfaces. Okay, means you are dividing your complete project into modules. Like if I am talking about online shopping is a software, okay, and that is divided into different modules. First module is your login module. Second module is to search module. And third module is there is the men, women, kids. Okay, the category wise modules are there. Then there is a payment module. Okay, feedback module is there. That is all your complete program or your complete project is divided into different modules. And that is the concept is a modularity, decomposing your complete program into smaller programs. And in this concept, you have to decompose your modules, and in each and every module, there should be a different functions. Okay, if I am talking about this is your main program on your screen, this is a main program, and this program is further divided into different modules, module 1 and module 2. And they also have a functions in it. A single module have functions, methods, operation to perform their task. And in another mode, there are further functions and operations or your methods are. Okay. And second point says that we basically allocate different functions to software modules and then implement them in a source. Okay. We have to decompose our program into modules, and there are different functions in our particular modules. Okay, if I am talking about login, there are different functions. Okay, that will be executed. Like if I will insert any invalid ID, that function will be shown on our screen. If I will put any wrong password, then another function will execute. That show us a error message or a dialog box is open. That are all executed by a function. That a function will be executed in a single module. In the same way, there is another module. If I am saying for search module, there are different functions in that module. Okay, if I am talking about payment module, there are different functions. It is cash on delivery. It is with a credit card or your debit card. That are all the functions. So they are talking about in your modules, there are different functions also. Okay, and they are related to each other. And that next point says that there should be a high cohesion and low coupling mix. Okay, what does this mean? I will show you on board. Okay, concept is your modularity in software engineering, and this is related to your software design. Okay. It is related to your software design. Okay, because we are in the base your concept that is software design, and in this there is a modularity. We have to divide our complete project. If I am talking about this is my online shopping project. Online shopping, or this is an online shopping program. Okay, then this program is divided into different modules. That is module 1. This is my login module. This is my login module. Then there is another module that is a search module. That is module 2. Okay, then there is another module that is the payment module. Okay, the same way we will decompose our complete project. Decompose our complete project into modules, and in these modules they have different functions. If I talk about function 1. There is a function 1 in module 1, there is a function 2 in module 2, there is a function 3, function 4. Okay, there is a function 3, function 4 in module 2, and there is another function in module 3. Okay, and this is the modularity is. Means your main program is decomposed into different modules. That is module 1, and I have given the example that is this is my login page, and this login page have a different function. Okay. There is a reflection. That is why now it is clear. I hope it is clear now. Okay, this is your main program, and modularity says that in your software design, this main code or your main design is decomposed into different modules. That is module 1. I am given an example that this is your login. This is come under your login 1, and in login there are different functions like F1, F2 is in module. There is search module, second module that is decomposed, and in this module there is another function that is F3, F4, and in the payment module there is another function. Okay, and what does modularity says that in modularity we have a decomposition of a program into a smaller program, and that we will perform while software designing, and after designing we will go for a coding. Okay, and in designing we will decompose that. Okay, then modules are decomposed. Okay, then in second point it says that in a single module, in an individual module, there are different functions. Okay, it can be that function 1 can be defined in your module 1, function 2 is defined, and function 2 will be called from which function? Function 1. That can be possibility. Okay, that can be the possibility. And the same in your next module, and in your third module, there is a dependency of function. Okay, dependency of function. Now we were talking about the word that is written a cohesion, and they said that there should be a high cohesion and low coupling. What does this mean? What is cohesion and what is coupling? Cohesion says that in your single module, there should be a functionality dependency on each other. Okay. Means in a single individual module, there should be a functional dependency of each function. I am talking about a single module. Okay. So they are saying that cohesion should be high. Means in single module, their function should be dependent on each other. Okay. And the same way, this module should have its own cohesion, and the same way module 3 have their own cohesion. Means in a single module, their functionality should be dependent on each other. It should be good to design your product in this manner. Okay. Your product will be in a proper manner if there is a proper functionality that is dependent on a single individual. That is a cohesion. And what is coupling? That is, there should be a less dependency on module. Okay. On different module. If I am talking about module, there is less dependency on each other. Okay, that is your coupling. Okay, I will explain it again. What is cohesion is in a single module, their functions or their methods that we will use, they have a higher dependency on each other on a single module. But what coupling says, there should be a low coupling while designing your product. Okay, cohesion should be high. High cohesion, low coupling while designing your product. Okay. And what is coupling is interdependency between two modules that should be low. That is your coupling. Okay. Dependency between these modules should be low. Why it is? If this module will make any error, that will affect this module. That will affect this module. If it is dependent on each other. If module 1 is dependent on module 2 as well as module 3, if there is any error in this module, they will affect module 3 as well as module 2. Okay. This is your cohesion and coupling. We will study in detail what is cohesion and what is coupling is. A simple definition is your cohesion is dependency between a function in a single module. Okay, next we will study 5 criteria for design module. Like design model, and the first criteria is your decomposition. Okay, that is modular decomposition. Second is modular composition. Third is your modular understandability. Fourth is your modular continuity. And fifth is your modular protection. Okay, first criteria is while designing your model. Okay, we're talking about our software design. While designing our product, we should keep in mind that our modular should be decomposed. Okay, decompose means your main program can be decomposed into different modules, and further different modules can be decomposed into sub modules. Okay. What does decomposition says that your main module can be decomposed into sub modules, and further this sub modules can be decomposed. Okay, that is your decomposition. Like in your BTech field, there is a different semester. Semester 1 students are there, semester second students are there, third students are there. That is your BTech is decomposed. Make a project in a way that your product can decompose. Means while creating a design, you can decompose your software or your project. Okay. So modular decomposition should be there. You can decompose your design or your product. Then composition. You can merge your modules. Okay. If there is some modules are there, you will compose it, make a main module. Okay. Then again, there is a sub modules in there. You can compose it and make a main module. Okay, the same manner you can decompose. There is also a composition for. Okay. Next is your understandability. Modules should be designed in the way that a user can also understand. User, customer. Okay, make a design that user or customer can also understand that module, how they are working. Okay. If we are making a DFD, I have got to that DFD is your data flow diagram. Data flow diagram it is. Okay. We will I am talking about understandability. Your third criteria. There is a concept of DFD, and DFD stands for data flow diagram. Okay. In this, we will make a graphical image, means this is our process 1. I can say that this is my login process. Okay. And after logging, I will go for a next process, that is search. Okay. After logging, if I am giving a valid ID password, then I will go for a next process, and it can be a search. Okay. Then again, there is a next module, that is your purchase. Okay. Purchase of item. Okay. These are your DFDs are, and according to this, if I will be the customer or the user, I will see this diagram. I can understand this product. Okay. I can understand this product. First of all, I will log in. Then I will go to a search page. Then after that, there is a purchase item. Okay. That is your module should be designed that it can be easily understood. Okay. If I have nothing knowledge about a software engineering or a software product or your software is, what I will do, I will see the diagram, and according to diagram, I will learn how they are working. Okay. This is your DFD. And in a single process, there are further sub process are there. Okay. Like if this is your 1.1, this is your 1.2, it will be your 1.2.1, 1.2.2, and further indexing should be mentioned. Okay. This is your modular understandability should be. Next is your modular continuity. Modular continuity is there. This is your fourth criteria. It is you will decompose your module in a sequence manner so that while composing them, there should be a proper sequence of statements are used. Like there should not be used any type of literal, okay, any type of go-to statement. Okay. There should not be any type of go-to statement or any type of constraints are there. That is, your modular should be in a continuous manner. Okay, you will divide your process modules in a continuous manner. That is, I have told you that there is a login page. Then you will go for your search page. Okay. Then you will go for your purchase. There should be a continuous. Okay. And keep in mind, you will not use any type of literal. Okay. The constant word that should not be used while coding. Okay. That should be keep in mind. There should not be use of any type of go-to statements. Okay. Because this go-to statements will create a problem while coding or while executing your code. Okay. So this is your module continuity. And last is your modular protection. Okay. Your module should be protected. Okay. Protected. How it can be protected? Using of proper data types. Okay. How it can be protected using your proper data type while coding. Like if there is integer values, you will use that integer. If have a short integer, you will write short, then you will give your value. In this manner, if you are giving a proper data type, if your value is in the float, you will give a proper data type. Okay. That all make your design proper. Okay. That is your modular protection can be according to this. Okay. Keep in mind, while designing your product, that protection should be there. Okay. Continuity should be there. Understandability should be there. Understandability according to customer also. Okay. This is all the criteria should be keep in mind while making the design. And now we will study the main concept of our modularity, that is your coupling. Okay, coupling, then we will go for cohesion. Okay, I have told you that if there are different modules, that is module 1, module 2nd, module 3rd. So the word I have written that inter. Okay, inter means there should be less coupling while making a design. Okay. If the design is good, then we will go for a call. Means your module 1 should be less dependent on module 2, less dependent on module 3, or module 3 is less dependent on module 2. That is your coupling says means inter between modules. Inter-modules dependency should be less. If I am talking about inter, this I am talking about more than one. Okay, more than one module dependency should be less. Okay, and it is measured in degree of interdependence between modules. This is the simple definition. Right. Right. Okay. Module 1, the definition is your degree of dependency. Okay, dependency between modules. That is degree of interdependence between modules. Okay, so module 1 is dependent on module 2. If it is dependent on module 3, they will create a problem. Okay, so while designing a product, keep in mind your coupling should be low. Means interdependency between modules should be. That is your coupling field. Okay. Then further, there are different level of couplings are there. Keep in mind what is coupling is. Coupling is between degree of dependency, interdependence. Okay, that is inter. I am talking about inter between module. Okay, inter. And in cohesion, that is intra. Okay, between single module. Okay, so that is like coupling should be low while designing your software. Okay, now we will study level of coupling. First is your content coupling. Next is your common coupling. Next is your external coupling. Next is your control coupling. Then there is a stamp coupling. Okay, these are the levels of your coupling. First is your content, then second common coupling, third is your external coupling, fourth is your control coupling, fifth is your stamp coupling, and further there is last is your data coupling. Okay, and these are the levels, but I have told you that your coupling should be low. Okay, so according to these levels, the best coupling is your data coupling. Okay, and the worst coupling is your content coupling. Okay, why it is? If in content coupling, I'm talking about content coupling now. If I will alter or change, if I will alter any value, then I am drawing a diagram here. Means if okay, if I'm talking about coupling, coupling means dependency of two modules between each other. Okay, means this module 2 is completely dependent on module 3. Okay, if I will alter or change any content in this, okay, if I will change any content or alter any content in this module, it will affect to this module. Okay, that is your coupling, content coupling stage. Okay, so according to design, this coupling is your worst coupling. Okay, and after that, common coupling. Common means if we are using a global variable. Okay, while coding, we are using a global variable. Okay. While we are using a global variable in our coding, it will also affect your code. If I am using a global variable here, okay, it is dependent on module 2, or you can say that module 2 is dependent upon module 1 and module 3 is dependent upon module 1. Okay, and here we have declared a global variable, but in module 2 we are using a different function or different data members, but we are assessing this global variable. Okay, this common for module 2 also, module 3 also. If there is any interruption or any type of error is in module 1, it will affect to module 2 as well as. That is your common. Common is if we are using a global variable in module 1 and we are dependent on module 1 from module 2 as well as module 3 from module 1. It will affect our sub part of our code or your sub program. Okay, these are your sub programs. Okay, this is your main that is divided into sub, and further there are sub part of your module. Okay, if there is a global variable in this, it will affect these two. If there is any change in the main module. Okay, that is your common coupling state. Okay, so keep in mind while designing a product, there should be a less common coupling. Okay, next is your external coupling. External means outside. If this is the module, there is another module in your program. Okay, external means this is the external one. This is the subpart of your this module, but it is not connected with this one. But these modules are connected, or the function that is written in this module. Okay, the function written in this module is called from this module. And calling is done from this module. Okay, that will also affect your coding. That is your external application. Okay, if I have written a function here, and that function is calling from another module that is not related to them or not connected to them via method or a function, but we are calling the function that is defined in this, but calling from an external part. That should also be a worst condition. Okay. Then there is a next control coupling, and in this between two modules, there is a communication between two modules. Okay, if this is a module 1, this is a module 2, there is a communication between two modules with reference to flag values. Okay. Control coupling says that there is a dependency between two modules and they are communicating with each other with the concept of a flag. That is your control coupling is. Okay. I have told you that in your coupling there is a degree of interdependency between a module, and here is your interdependency between modules. If they are communicating with each other, they should be communicated with a flag value. Okay, next is your stamp coupling. In your stamp coupling, your data structure. Okay, module 1 data structure. Stamp coupling is your data structure. In stamp coupling, your module 1 and module 2, if there is any change in data structure of or any structure of your module 1, and there should be also information to module 2 that module 1 have changed their structure, okay, or value, or any type of there is change or alternate is there. So from module 1, if there is change in module 1, all the information or the structure should be informed to module 2 because they are dependent on each other. That is stamp coupling is. And in this stamp coupling, we are talking about a data structure. If the structure of module 1 is changed, that same should be passes to module 2. Okay, so that module 2 can understand the concept of module 1. Then there is the data coupling. Okay, and data coupling is that you are passing a parameter. From module 1 to module 2. Okay, data values are changed. Only data values are changed. That is your data coupling set. Passing a parameter then. Okay, from module 1 to module 2. That is, if there is an int a value that is available, a having a value 10, b value have a 12. If the same function that is written in module 1 is calling from module 2, then that value should also be given to a module 2. That is your data coupling set. Is passing a parameter values also be informed to module 2 if there is any change in module 1. Okay, that is your data coupling. And coupling, we have said that while designing a product, your data coupling is the best coupling. This is the low concept in your design phase. So low coupling should be there. And in simple definition, it is degree of interdependence. Interdependence between modules. Okay. This is the simple definition of your coupling is, that is interdependence between modules. Okay. Next is your cohesion. Cohesion, and it is intra interdependence. In a single module. Okay, if there is a single module, that is module 1, and they having a different function F1, F2, F3. Okay, means in a single module, their function should be dependent on each other. Okay, that is a cohesion state. It should be high. Between a single module, their functionality should be interact with each other. Okay, and cohesion should be high while designing the product. Okay, that is your cohesion is, in a simple definition, the element of the module are functionally related. The element of the module are functionally related. Means their functionality of their functions are related to each other. That is your cohesion. Okay, and while designing, your cohesion should be high. Okay, then we will study the different level of cohesion. First is your functional cohesion. Okay. First level is your functional cohesion, then there is a sequential cohesion, and then there is a communication cohesion. Fourth is your temporal cohesion. Then there is a logical cohesion, and sixth is your coincidental cohesion. Okay, these are the different levels. First is functional cohesion, then sequential cohesion, communication cohesion, temporal cohesion, logical cohesion, and coincidental cohesion. And in this, we have said that while designing a product, cohesion should be high. And we also define that there is a functionality that are related to each other in a single module. This element of, the definition is the element of single module, their functionality should be related. And here is the first cohesion, that is functional. And this should be high. Okay, means this is the best. You can say that this should be high. The functionality dependency should be high. Your cohesion is high, and coincidential should be low. Okay, this coincidental cohesion should be low, and your functional cohesion should be high while designing your program. If your functional cohesion is high, your cohesion is high. Okay. And further we will study what is functional cohesion is, spatial cohesion is, communication cohesion is, temporal, logical, and logical. We have to keep in mind while studying this concept cohesion, we will arrange this concept in the same way. First is your function, then spatial, then communication, temporal, logical, and coincidence. Last is your okay, these are the concepts or the level of your cohesion is. Okay, and before that we have studied coupling and their different levels. Now we will study all these concepts in detail, levels, their what they work for. Okay, what are the functionalities of different levels. And this is your first concept, that is what is modularity. Modularity is decomposing your program, and high cohesion should be there. Okay, and low coupling should be there within among components. Okay, between, if we are talking about cohesion, that is a single module is there. If we are talking about coupling, between intermodule, okay, and cohesion is intra. Then there is a different criteria of your design methods, and there is decomposition, composability is there, understandability, continuity, and protection. These are the 5 criteria for your software design. Keep in mind, then we will design these the software design according to these criteria. Your design should be decomposable. It should be composable. Understandability should be there. Okay, continuity should be there, and protection is mandatory. Okay, what is decomposition is? This criteria is met by decision method if the method score the decomposition of problem or your program into smaller subprograms. Okay, that is your decomposition. Yes, and in general method will be repetitive. Okay, means if we are decomposing a main program, and there is also a sub decomposing of the sub programs also there. Like in this diagram, there is a system level, there is a sub level, then sub level is further decomposed. That repetition is there. Okay, if there is a system level, it is decomposed, and this level is also further decomposed. Repetition is there. Okay, so decompose your main program into your sub program so that it can be easily designed. Then there is a top-down approach is there while designing your product. Module 1 is decomposed into module 2 and module 3, and further module 2 is decomposed into a module 4 and 5. This is your top-down approach of your decomposition. Okay. Then composability is a method satisfy this criteria if it lead to the production of modules that may be freely combined. Okay, now first of all we have decomposed it. Now after that, after completing all the modules, we will combine that module and make a complete software. That is your composability. Composability is directly related to the issue of reusability. Okay. Composability is directly related to the issue of reusability. Means there are problems in the reusability that will resolved or you're resolved by your composability concept. Okay, the problems that are arising while reusability you can resolve with the concept of a composability concept, because using your previous code, we will propose our new code. Okay. The word we have used in our yesterday practical, there is the existing system that is reusable, that existing system can be reusable, and using that design or document, we will create a proposed system. Okay. Then there is an example that numerical algorithm group libraries contain a wide range of routines, or you can say that subroutines, for solving a problem in linear algebra differential equations. Okay, means this is the example. We are using a numerical algorithm that is predefined, that is existing system, and using that system, we are solving a new problem that is of linear algebra differential. This is the example, and that is using a previous code or previous design, we are creating a new design. Okay, that resolves by the concept of your composability. Then modular understandability, a design method satisfies this criteria if it encourages the development of modules which are easily understandable. Okay, development of modules which are easily understandable by user, by customer, or also by a team leaders also, or by a team members also. Okay, the example is there. Right? If we are making any project, it takes thousands of lines. Okay, it will take 1,000 of line of code, and containing no procedures. It's just a long list of sequential statements. Okay, if there are 1,000 of line, there are number of statements, there are number of functions. Then main solution is that decompose that statement into different sub levels. Okay, then divide it into 20 blocks, each 50 statement. That is saying that complete program is divided into a 20 block, and in each block there is a 50 statements. That can be easy to design, easy to maintain, easy to code. Okay, so understandability should become easier if we will decompose our program. Then there are another points for understandability, that is, can the component be understood on its own? Okay, if there is a proper decomposition, okay, into different statements, that can be easily understandable. Are meaningful name use? Okay, for each and every module, there is a proper naming should be there. If it is there, it is easy to understand. Okay, well designed. Okay, well documentation is there. Okay, proper algorithm naming should be there. If this is done by us or as a team member, then it is easy to understand. Okay, next is modular continuity. A method satisfies this criteria if it lead to the production of software such that small change in the problem specification lead to the change in just one module. Okay, continuity means if there is any change in a single module, it will not affect to another module. Okay, only a single module can change it and make a continuity in it. That is this point says. Okay, I will read it again. A method satisfies this criteria if it lead to the production of software such that a small change the problem specification lead to change in just one module. Okay, if there is any change, only change in one module, not in all the modules. Okay, there is module is written, but in this there is a single module it's talking about. Okay, if there is any change, that is change in a single module only, not in all the modules. If there is a change in all the modules, means your coupling will become higher. Okay, because interdependency is there. If there is change, all modules should be changed. So we have studied that there is a low coupling. Then your design is good. Okay. Then protection is there, modular protection. A method satisfies this criteria if it is yield architecture in which the effect of an abnormal conditions, okay, abnormal conditions at a runtime only effect on a module. Okay, they are talking about no, abnormal, like a go-to statement that is used in your coding. If there is a go-to statement, okay, that will affect your code. That will affect your code. So there is limit use of go-to statement should be used in your coding, and a proper conditions are used that will not affect your code or your design. Okay, a proper conditions should be used that do not affect your code. Okay, that is abnormal conditions executed when we are using a go-to statements in our code. More than 5 or 6 go-to statements are used, they will affect our product. Okay, so they are also saying that your modular should be protected. Okay, for that using int type where sub range or short type are appropriate, and there is also a solution that you will use your data type for your sub range. Okay, that is integers data type should be used, short data type should be used if they are in your coding. Okay. Then there is a coupling. What is coupling is a measure of strength of interconnection between a system component. And system component here is your module. That is a measure of what is the definition of a coupling is a measure of the strength of, or you can say that a degree of interdependence between your module is. That is your coupling is. No. Okay. Sorry. Your coupling is your a degree of dependence among a components. Okay, and component is your module is. This is in this diagram there is no dependence. Means no single module is dependent on another module. That is no dependence. Loose dependency is there. Somewhat is dependent on some another module. That is your loose coupling is. Okay, and here is the high coupling. Okay, so while designing our product, we should keep in mind there should be a low coupling is. Dependency between your modules should be low. Okay, and that is in your data coupling is. Here is your level of couplings are. High coupling is in your content coupling and low coupling is in your data coupling. Okay, your data coupling is a low coupled concept. Okay, so content coupling is your worst case. Okay, and in this, when module uses or alter data, if there is change in the data, it will affect the different module also. That is your content coupling is. Common coupling, two modules communicate via global data. Okay, I have shown you with the diagram with an example. If two modules are communicating via a global data or via a main module, that is your common coupling is. It will affect your design or your coding. So Content coupling should be low, common coupling should be low, external coupling should be low. And what should be there? There should be a data coupling. That is the best for a coupling is. What is data coupling is? Communicating via parameter pass, via value that is declared. Okay, value. Only that value can be passed. That is the best method. Okay, between the two modules. The parameter passed are only those that the recipients need. Recipient is your different modules. Okay, so coupling is degree of interdependency between your modules. That is your coupling is. So these are the range, or you can say that these are the levels. First is your content, then after that common, then after that external, then control, then stepping, and last is your data coupling. That is your, and last is no data coupling. That is no dependency is there. That is the also the best. If there is no dependency, means your product is a good product, well designed. Then cohesion is a measure of how well a component fits together. Means we are talking about single module function dependencies. Okay. Okay, that is your cohesion is a measure of how well a component fit together. Okay, and in a single module, how their functions are related to each other. That is your cohesion. And there are further different level of cohesions are. These are your cohesion levels. Okay, there is a coincidental cohesion that is the worst, that is weak. Okay, and what is the best? That is functional cohesion. Okay, coincidental cohesion are there, logical cohesion are there, temporal. Okay, logical is your component which performs similar functions. Okay, similar functions they perform. In your single module, if the different functions are there and they are performing a single operation, that is your logical association or logical cohesion. Temporal, they are depending on a time. Okay, component which are activated at the same time. Component means module or your functions that now we are talking about single module, and in that there are functions. Okay, the functions that are activated at a single time, that is your temporal cohesion. That is also should be low. What should be high? Your functional cohesion should be high. If your functional cohesion is high, your product design should be strong. Your coding will be strong. Okay. Then communication cohesion is there. All the element of component operate on the same input or produce the same output. Okay, that is component work on same input as well as it produce the same output. That is communication cohesion. Then sequential cohesion is the output for one part of component is the input for the another part. The output produces from one function, it will work as an input from the second input of a second function. That is your sequential sequence manner, like your waterfall is. First phase will complete, then you will go for a second phase. Second complete, then you will go for a third phase. That is your sequential cohesion is. That is your function is related to each other. If first function will be executed, then we will go for a second function in a single module. That is your cohesion is. Okay, and further these are your coincidental. Okay, coincidental means that is a part of component simply bundled together. They are bundled together. Okay, this should be a weak in your cohesion part. If it is in a coincidental manner, then your cohesion is weak. Okay, then further there is a logical. Mean A is inherit from a second module or a second function. Okay, then third function is inheriting a second function. That is your logical. This should also be low. Okay, temporal means all the functions are activated at the same time. That is temporal cohesion is. Okay, then further communication. Okay, they are communication with a single server. If this is a database, all the functions are communicating at the same time with a single database. Okay, that is communication. Cohesion is that it should be a medium. Then sequential, A output work as a B input, B output work as a C input. These are the function in a single module. Then there is a functional, that is different functions are used and they are related to each other. Okay, this is your cohesion is. Cohesion should be high, coupling should be low. Okay. Then cohesion as a design attribute. Okay, your cohesion should be high, then your design should be good. Okay, not well defined, often difficult to classify cohesion. Okay, if your cohesion is not well defined, it will be a problem for your design. Okay, so your cohesion should be well defined. Okay, your superclass, subclass, inheritance, all should be defined properly and they are used in your coding. Okay, that should be make your product effective. That is your concept of your software design is. Okay, if you have any question, you can raise your hand or can message. Okay, and I will launch a poll. You have to answer that question. First question on your screen is, if you have any question, you can ask.